Alright, my dear learners, this is our lesson number 2 under light energy. Remember, this is revisionug.com. Remember to subscribe, share and like. This is the online platform that provides education in its simplicity. In our lesson number 2, we are now going to discuss the properties of light. We are now going to understand how does this light behave. So, properties of light. We are going to understand how does light behave. Property number 1, light can be reflected. Yes, light can be reflected, and these properties we are going to study one by one into details. What does this mean? It means that if we are having the sun, remember the sun is the major source of light, then it is going to produce a light ray. When it reaches down here, it is now going to go back or to bounce, and this bouncing is what we call reflected. So light can be reflected. Or when you get a mirror and you put it under the sun, then you are going to try to get a reflection. So meaning that light can be reflected. Number 2, light can be refracted. Light can be refracted. Now this is bouncing, and this one in simple terms we are going to look at this one into details. That is the bending of light, as you are seeing in this diagram. In this diagram you are seeing light entering, then it is coming out when it is bending. That is what we call refraction. So light can be reflected. Then light does not need a medium of transmission. Light does not need any carrier, does not need any matter, does not need molecules to carry it from one point to another. So light does not need a medium of transmission. So like other forms of energies, especially the sound energy, which needs to be conducted from one point to another by molecules of matter, but light does not need a medium of a transmission. Light travels in all directions. In all directions. That's why when you are in a sitting room, you use only one bulb and it produces light, and you see each and every part in the room, meaning that light can travel in different directions. In all directions, we are having one sun, but we are all receiving light from that one sun, meaning that it can go in all directions, not only at your area but in also other areas. Light travels in all directions. Then number 5, light travels in a straight line. I'm repeating, light travels in a straight line. That's why we cannot see around corners without using a special tool like a periscope. Why? Light does not make corners, it just travels in a straight line. So light travels in a straight line and in all directions. Then another property here, light travels faster than sound. Light travels faster than sound. Light travels faster than sound. So property number 1, we said light can be reflected. Light can be reflected. Light does not need a medium of transmission. Light travels in all directions. Light travels in a straight line, and light travels faster than sound. Yes, light travels faster than sound. Now we are going to look at some evidences that show that light travels faster than sound. Yes, we are going now to look at the evidence, the proof, the things that show that light travels faster than sound. The evidence is 1. During a thunderstorm, you know a thunderstorm, when it is raining and it is a little bit cloudy, clouds are moving, they are going to form that static electricity which is called lightning. Now that is the thunderstorm. We are having a sound and also light. So during a thunderstorm, I think now we are at the same page. During a thunderstorm, lightning is seen before hearing thunder. Yes, is seen before hearing thunder. Hearing thunder, that is the sound coming from the cloud. That one is the thunder. Then what we first see? We first see the lightning chip. Then we get a sound. What does that show? That shows that light has come first, then sound next. Therefore, light travels faster than a sound. Also, another evidence here. When you look at an aeroplane we are seeing it because of light, and also it produces sound. So you can see, is an aeroplane light? No, an aeroplane is not light, but as it is traveling, we are seeing it by the help of what? Light. So as we are seeing it by the help of light, then this means that one, we first see that airplane, then we hear the speed, we hear the sound of an airplane. Therefore, what does that mean? That means that an airplane, okay, let us first write this one. This means that the evidence is an airplane is seen before its sound is heard. Its sound is heard. Therefore, we have also that one there. Let me hope that we are still at par. We are still at two together. So after you have understood the evidences that show that light travels faster than a sound, now let us look at the speed of sound. The speed of sound, then sound travels 300,000 kilometers per second in air and vacuum. Remember, a vacuum is a space without matter. Therefore, light travels faster than sound in air. So I think we are still together. Even another evidence here, at a race track, like when you are going to run, they say set on your marks, then they clap. Then what we first see here, we first see the clapping, then we hear the sound of the clapping, or the clapper, or the wooden clappers. That means that light travels faster than sound. And from a distance, sound of an axe, if you are chopping wood, sound of an axe is heard after you have seen an axe strike. The axe first strikes the wood, then after you hear the sound. So seeing is aided by light. Are we still together? Okay, now with that one, let us now take some comparisons between the forms of energies. Comparisons, and this word comparison, it means we are now comparing. We are now going to do what? To compare. As we are comparing, we are going to start by comparing the similarity, getting the similarity. How are they the same? The similarities are between heat, light, and sound. Now, how are they the same? Here we are having light, here we are having heat, light energy, and also here we are having sound, that is the thunder, because this is lightning. Now, how are they the same? All of the three, all are forms of energy. Yes, they are all forms of energy, and two, all the three can be reflected. Yes, light can be reflected. Heat, when you look at the vacuum flask, has the silvered walls that reflect heat back to the substance. So heat can be reflected. That's why the Stevenson screen is painted white, hospitals are painted white, refrigerators are painted white to reflect that heat. And also sound can be reflected to form what we call an echo. Okay, let us now look at another comparison, and this comparison, it is now the difference between sound, between sound and light. Yes, the difference between sound and light energy. How are they differ? How are they different? One, light does not need a medium of transmission. light, from its property, we said light does not need a medium of transmission, whereas sound needs a medium of transmission. That's why a sound cannot travel through a vacuum, simply because in a vacuum there is no any matter, because it's the matter which has molecules that are going to conduct or to transmit the sound from one area to another. So with the light energy does not need a medium of propagation, whereas the sound needs a medium of propagation. Then another difference is light travels faster than a sound. Yes, light travels faster than a sound. Okay, so from there now we are going to move on and look at another item, and this is light rays and beams. This is light rays and beams. All right, now let us understand what is a ray. What is a light ray? So a ray of light, a ray of light is the path followed by light. Yes, is the path taken, or the path followed by light, where light is going to pass. As you are seeing these lines, so they are showing you where light is passing. When you look at this sun producing light, now this path followed by light, that is what we call a ray. So a ray of light is the path followed by light, and this ray is represented by an arrow. It is represented by an arrow. Yes, so if you do like this one, that is just a line. So to show that it is a ray, you put an arrow there, but the arrow don't put it at the head. No, then this one is showing direction. But light, this one shows direction, but this one shows the path taken by light. So this is our light ray, showing us that light is coming from point A going to point what? Point B. If it is just like this one, it is coming from C going to what? To a D. Then again, a ray of light is represented by a straight line with a what? With an arrow, as you've seen there. Then we are having what we call a beam. Then let us understand what a beam is. Then a beam of light, a beam, don't just say beam, a beam of light is a group of light rays. Is a group of what? Light rays. When you have very many parts like this, these ones are very many, so they are in a group and they are traveling in the same direction. So is a group of light rays are traveling in the same direction. So a beam of light is a group of light rays are traveling in a same direction. Therefore, my dear learner, we are going now to look at the types of light beams, and there are three types here. One, there is what we call the parallel beam of light. Then two, we have what we call convergent. The word is convergent or the converging. So convergent or the converging. Then number three, we have the divergent or the diverging beams of light. Then what is a converging beam of light? Let us start with a converging beam. Then with a converging beam of light, so this is a beam of light where the light rays are from different sources and meet at a point. They are from different sources and meet. So to meet means to do what? To converge. So if you look at this light ray is coming, then we are having also this one coming, and again we have another one coming. So as they are coming, now these arrows, they are showing that they are coming from different areas. Then they are meeting at a certain what? Point. So they have converged. Then this one becomes a convergent beam. Then divergent beam, it means that they are coming from one point of a source, then they are going to different directions. Therefore, this one becomes the divergent. For example, the divergent is produced by the headlamps, of those vehicles, of bicycles, the headlamps, the bicycle headlamps, the car headlamps. Then we have the torches, even the sun, the electric bulbs. So they are producing, or they are giving us what we call a divergent beam. But our eyes are collecting light from different points and collect them to a one source, and we see the objects. And lastly, we are having the parallel beam. Now with a parallel beam of light, light rays cannot meet, they are parallel to each other as you are seeing. Therefore this one becomes the parallel beam of light. So this is parallel beam, this is converging, this is diverging. Now when you look at this one, this is the parallel beam of light. Now this is divergent, so they are coming from one point to different areas, and now they are coming from different areas and collecting at a point. So this is convergent beam, divergent beam, and the parallel beam of light. Or if you can compare here, this is the convergent, this is divergent, this is the parallel beam of a light. So that is those are the beams and rays of light. But these beams and rays are very important. Now let us first look at the importance of the beams of light. Remember, we've said a beam is a collection of light rays traveling in the same direction. One parallel beam of light enables us to see directly in front of us. So the parallel beam of light enables us to see what is directly in front of us. What is directly in front of us. Then two, the divergent beam enables us to see over a wide area. So divergent, those ones that are scattering, they enable us to see over a wide area. Then three, the convergent beam enable doctors to examine organs. This is very important. So the convergent, because they are using the microscopes, the convergent beams enable doctors to see organs inside our bodies, such as to examine our organs, such as the nose, which are dark. Yes, they are dark. My dear learner, with that, let us now go and get our activity. Number 1 says, briefly explain the following terms. Briefly explain the following terms. The following terms: A, ray of light; 2, B, a beam. Then number 2, study the diagram. Study the diagram below carefully and answer the questions that follow. So we have this one, and this is Q. Then we also have this one here, like this. This is P. Name the beams shown by letters. Name the beams shown by letters P and Q. State N1 importance. N1 importance of the following beams of light shown by the letter P and Q. Number 3, what type of beam of light do the following objects produce? 1, torches; 2, car headlamps. Car headlamps. Then write any 2 properties of light. write any two properties of light. Why are we unable to surround corners? Why are we unable to see around corners? Then give any two similarities, between light and sound. Then why is lightning first seen before thunder is heard? Why is lightning first seen before thunder is heard? Alright, you've been a good learner. Keep up with revisionug.com. We meet in the next lesson, lesson